In the lesson 7.6 example, Can You Spare a Square?, we're going to construct and interpret a confidence interval for mu, which is a population mean. Christina and Rachel randomly selected 18 rolls of generic brand toilet paper to measure how well this brand could absorb water. To do this, they poured a quarter cup of water onto a hard surface and counted how many squares of toilet paper it took to completely absorb the water. Here are the results from their 18 rolls. So some of the rolls, it only took 21 or so, as low as 20 squares to absorb all the water, and some it took as many as 29. What we want to do is construct and interpret a 99% confidence interval for the true mean number of squares of generic toilet paper needed to absorb 1/4 of a cup of water. So it's probably somewhere in the 20s. We can see that all of our answers were in the 20s. We need to figure out what the true mean is, or create a confidence interval that we think will capture the true mean. So there's 4 parts to this problem. First thing we need to do is state what we want to do. We want to estimate mu, the true mean number of squares of generic toilet paper needed to absorb 1/4 of a cup of water. We want to estimate mu with 99% confidence. Now we're going to plan. We want to run a 1-sample t confidence interval for mu, but first we have to check the conditions. There are 2 of them. The first was this selected in a random way? Christina and Rachel, it does say randomly selected the 18 rolls of toilet paper. So we're good with that one. The second condition is an either-or scenario. Is the distribution normal that we want to use, or is the sample large enough? The sample size of 18 is small, that is, it's smaller than 30, so we have to check the dot plot of the actual data that we have, and we need to see if it shows outliers or strong skewness, any obvious signs of non-normal behavior. Here's the dot plot. We see a little bit of skewness, but not really a lot, and most of the dots kind of tend toward the middle of the distribution. So there's nothing really here about outliers or strong skewness that gives us any pause. We're going to give ourselves the check mark there. And with both of the conditions met, we can continue on with our 1-sample t confidence interval. After the plan stage, we actually want to do, that is, perform the confidence interval. We want to calculate it. In this problem, we have some information that we know. We know the sample mean x bar, we know the sample standard deviation s, and we know the sample size was 18. So we want to construct a 99% confidence interval with 17 degrees of freedom. Sample size was 18, so there are 17 degrees of freedom. Using table B, we can find in the 99% confidence column and the 17 degree of freedom row that t star is equal to 2.898. So now we have all the information we need for the confidence interval. We're just going to substitute the numbers that we have in and calculate to get 24.94 plus or minus 1.95. That gives us 22.99 to 26.89. Last thing we want to do is conclude. What does this interval tell us? We can say that we're 99% confident that the interval from 22.99 squares to 26.89 squares captures the true mean number of squares of generic toilet paper needed to absorb 1/4 cup of water. If you'd like to try a problem like this in your book, you can try exercise 5 in this section.